Alright, so I wanted to show you what I'm going on about lately over here, and what I'm doing is a Prony test, which is a test for a motor torque in a given RPM, or what you all commonly know as HP, horsepower. So I wanted to see how much force I get out of a motor in a specific RPM. And doing that is quite tricky. It's very easy to just hold the motor down until it's stopping completely and then see how much force it puts down and calculate that, and then you have the stall torque. That's nice, but checking out the torque that the motor outputs at a given RPM is a little bit more tricky. So let me show you the setup here. The first very interesting thing over here is a encoder wheel, which is made of a little PVC sheet with a little black marker on the bottom. And over there is the sensor and emitter. The emitter is on the left. It's an LED, infrared LED light, and on the right side is the sensor that's going to sense it. Now the LED is getting 5 volts from this little circuit, and the sensor is getting the same. It will output something, and it's going to go over that little resistor, and anyway that's connected to the computer through this data acquisition thingy, and it goes to the computer. What I'll get on the computer is a little graph, and right now it points at little less than 4 volts, and that's because the light is going through and there's no blockage for the light. Right now the sensor is not going to get any infrared light, and that's why the input voltage had gone down to 1 volt or a little bit more. So when the motor rotates and the light gets broken apart, there's gonna be a few different modules here, and the bottom line is that that's gonna make an RPM signal for me, and I'm gonna know how fast the motor is turning. That's the first thing that I needed to know. Now the second thing was to know how much power I'm giving to the motor. So how much electricity I'm outputting to the motor. The way that I did that was, first I've got an Arduino Nano over here, and that's connected to a potentiometer. With a potentiometer I'm able to change the value of the PWM signal, and right now it's set up to half duty cycle, so that's half the time it is working and half the time it's not working. Now the Arduino only gets 4 volts, and on one of the output analog output channels, that's gonna go into this little thing, which is an optocoupler. In the optocoupler is a very similar setup to what I've shown you here, only that there's nothing in the middle. So whenever the LED shines on one side, the other side is going to conduct electricity. The other side is connected to the high power circuit, which is 12 volts. It's not very high, but it's definitely more than the Arduino can handle. And there's a MOSFET over here, and then a diode over there, and they work together to give the motor the right kind of current and voltage that it needs. So basically the setup is a PWM signal coming from an analog channel out of the Arduino, goes into the optocoupler, and then the other side, the high side of the optocoupler, opens up when there's a light shining. The reason why I needed to use an optocoupler and I couldn't go straight from the MOSFET gate to the Arduino was because the Arduino only gets about 3.9 volts, and this MOSFET needs about 4.5 volts to completely open, if not more than that. So I wasn't really giving it enough voltage, and the motor speed was affected. I had to use the optocoupler to keep using the same MOSFET. So in this way, and with this setup, I was able to just start the motor and put a specific torque that I was interested in, and that was creating a specific RPM, and I figured that the speed that I was interested was about 800 RPM. So the next thing that I'm going to do right now is I have this weight over here, and I'm going to set it on 0 when, just like that. And now that it's set up, what I'm going to do is to measure by friction over here between these two parts. I'm going to measure how much force the motor is outputting, and I'll do that when the motor is going to hit 800 RPM, which is what I'm interested in. I'm just going to set it on 0 again. Alright, and so let's go. I'll start the motor. Now we'll put enough. Get the speed down. That's pretty good. Yep. And it reads about, yep, about 15 grams. That's great. That's all I needed to know. Now I have to take those 15 grams and multiply it by this distance, which is the lever distance, the length of the lever, and that is 75 millimeters. So 75 millimeters times 15 is 75 times 15 is 1,125 grams per millimeter. So I'm actually interested in grams per centimeter, so I'm just going to divide it by 10. That's 112.5 grams per centimeter. That's the torque that my motor is outputting at 800 RPM when it gets half PWM duty cycle. So that's what I'm doing right now. That looks difficult and it looks complicated, but I don't know, when you know what you're doing, it's easier than when you don't know. Alright, I hope you enjoyed it.